As of the 2020 National Electrical Code, or NEC, the overload relay of a contactor is no longer permitted to break the neutral conductor. According to NEC Article 430.31a, all overload devices, including those in contactors, must open all ungrounded conductors when an overload occurs. This means that the overload relay must break the circuit on the line side of the contactor before the neutral conductor. The rationale behind this change is that breaking the neutral on the load side of the contactor can create an unsafe condition known as phantom voltage. When the contactor opens the neutral, there is still potential on the load side due to the capacitance between the load and ground. This can result in shocks or other hazards to personnel who may contact the load. There are a few exceptions to this requirement. Firstly, if the neutral conductor is connected to the neutral block of the contactor. Secondly, if the neutral conductor is used to provide ground fault protection. Thirdly, if the contactor is part of a motor control circuit and the motor is protected by ground fault circuit interrupter, or GFCI. The implications of this code change are significant. Contactors with overload relays that break the neutral must be replaced or modified to meet the new requirements. Overcurrent protection devices, or OCs, must be installed on the line side of the contactor ahead of the overload relay. These changes aim to enhance safety and reduce the risk of electric shock. It is important to understand the specific requirements outlined in NEC Article 430.31 to ensure compliance and maintain a safe electrical system. Phantom voltage can present a serious hazard. By breaking the ungrounded conductors before the neutral, the risk of phantom voltage is minimized, protecting personnel from potential electric shock. When an overload occurs, the overload relay is designed to trip and disconnect the power supply to the motor or other connected equipment. Prior to the 2020 NEC, some contactor designs included overload relays that would interrupt the neutral conductor in addition to, or instead of, the ungrounded conductors. The NEC now mandates that the overload relay must open all ungrounded conductors. The ungrounded conductors are the conductors that carry the voltage, typically referred to as the hot wires. By opening these conductors, the power supply is effectively cut off, preventing further current flow to the load. This ensures that the overload condition is addressed promptly and safely. The reason for requiring the opening of all ungrounded conductors is to prevent a situation where the load remains energized through a path created by the neutral conductor. If the neutral conductor is broken while the ungrounded conductors remain connected, a voltage potential can still exist on the load side. This voltage potential, known as phantom voltage, can be hazardous to personnel who may come into contact with the equipment. The capacitance between the load and ground can create a path for current flow even when the neutral is disconnected. This capacitance can store charge, resulting in a voltage potential that can cause electric shock. The level of phantom voltage depends on various factors, including the capacitance of the load, the voltage of the system, and the impedance of the ground path. While phantom voltage may not always be high enough to cause immediate serious injury, it can still create a shock hazard, especially in wet or damp environment. It can also interfere with the proper functioning of sensitive electronic equipment. To prevent the occurrence of phantom voltage, the NEC now requires that overload relays open all ungrounded conductors before interrupting the neutral conductor. This ensures that the load is completely de-energized, eliminating the risk of electric shock from phantom voltage. There are a few specific scenarios where exceptions to this requirement may apply. Firstly, if the neutral conductor is connected to the neutral block of the contactor. In this case, the neutral conductor is considered to be part of the grounded system and is not intended to be interrupted by the overload relay. Secondly, if the neutral conductor is used to provide ground fault protection. Ground fault protection is designed to detect and interrupt ground faults, which are unintentional connections between a conductor and ground. In this case, the neutral conductor may be intentionally interrupted to provide ground fault protection. Thirdly, if the contactor is part of a motor control circuit and the motor is protected by ground fault circuit interrupter, or GFCI. A GFCI is a device that detects ground faults and interrupts the circuit to prevent electric shock. In this case, the GFCI provides an additional layer of protection, and the overload relay may not be required to interrupt the neutral conductor. The implementation of this new requirement has several implications for electrical installations. Firstly, contactors with overload relays that break the neutral must be replaced or modified to meet the new requirements. This may involve replacing the entire contactor or modifying the existing overload relay to ensure that it opens all ungrounded conductors. Secondly, overcurrent protection devices, or OCPs, must be installed on the line side of the contactor ahead of the overload relay. OCPs, such as circuit breakers or fuses, are designed to protect the circuit from overcurrent conditions such as short circuits or overloads. By installing OCPs on the line side of the contactor, the circuit is protected from overcurrent conditions before the overload relay can trip. The combination of OCPs and overload relays provides comprehensive protection for the electrical system. These changes aim to enhance safety and reduce the risk of electric shock. By preventing the occurrence of phantom voltage and ensuring that the load is completely de-energized during an overload condition, the risk of electric shock is significantly reduced. This protects personnel from potential hazards and improves the overall safety of electrical installations. It is important for electrical contractors, engineers, and technicians to be aware of this new requirement and to take the necessary steps to ensure compliance. This includes reviewing existing installations to identify any contactors with overload relays that break the neutral and replacing or modifying them as needed. It also includes ensuring that OCPs are properly installed on the line side of the contactor. By adhering to the NEC requirements, electrical professionals can contribute to a safer and more reliable electrical system. The National Electrical Code, or NEC, serves as the benchmark for safe electrical design, installation, and inspection to protect people and property from electrical hazards. It is developed by the National Fire Protection Association, or NFPA, and is updated every 3 years to incorporate new technologies and best practices. Compliance with the NEC is essential for ensuring the safety of electrical installations. NEC Article 430 covers motors, motor circuits, and controllers. This article provides detailed requirements for the selection and installation of motor components, including overload protection devices. NEC Article 430.31 specifically addresses motor overload protection. It outlines the requirements for overload relays and other overload protection devices used in motor circuits. The requirements in NEC Article 430.31 are designed to protect motors from damage due to overloads and to prevent electrical hazards. An overload is a condition where a motor is subjected to excessive current for a prolonged period. This can cause the motor to overheat and potentially fail. Overload relays are designed to detect overload conditions and trip the circuit to protect the motor. The NEC requires that overload relays be selected and installed according to the motor's full load current and service factor. The full load current is the current that the motor draws when operating at its rated horsepower and voltage. The service factor is a multiplier that indicates the motor's ability to handle short-term overloads. Overload relays must be capable of tripping the circuit before the motor is damaged by the overload. In addition to overload relays, the NEC also permits the use of other overload protection devices, such as thermal protectors. Thermal protectors are devices that are embedded in the motor windings and directly sense the motor's temperature. When the motor's temperature exceeds a certain limit, the thermal protector trips the circuit to protect the motor. The NEC requires that thermal protectors be selected and installed according to the motor's temperature rating. The NEC also includes requirements for the location of overload protection devices. Overload relays and thermal protectors must be located in a readily accessible location where they can be easily inspected and tested. They must also be protected from physical damage and environmental conditions that could affect their performance. It is important to note that the NEC is a comprehensive document that covers a wide range of electrical topics. Electrical professionals should consult the NEC and other relevant standards to ensure compliance and maintain a safe electrical system. It is important to stay up to date with the latest edition of the NEC and any applicable local codes and regulations. Changes to the NEC can have a significant impact on electrical installations. It is crucial to understand these changes and to implement them correctly to ensure safety and compliance. Proper electrical design, installation, and maintenance are essential for preventing electrical hazards and protecting people and property.